Hello everyone. So today we are going to start with our lecture 5, that is diagrammatic representation of trigonometric functions in a unit circle. So till date we have sought about the relation between a radian and a degree, and then we saw some of the trigonometric ratios and how to derive the different trigonometric ratios from one to another. And also we saw the waveforms and some related terms, that is amplitude, vertical shift, period. Then we saw phase, phase difference, and path difference. Let us not waste time and start with our main topic of today, that is diagrammatic representation of trigonometric functions in a unit circle. So, as we all know, there are six trigonometry ratios, that is sine theta is equal to perpendicular upon hypotenuse, cos theta is equal to base upon hypotenuse, tan theta is equal to perpendicular upon base, cot theta is equal to base upon perpendicular, secant theta is equal to 1 over cos theta, or that is hypotenuse over base, and lastly we have cosecant theta, that is 1 over sine theta, that is hypotenuse upon perpendicular. So these are some of the trigonometric ratios. Let us now try to derive them through the circle. So why we are taking unit circle? Because we see that in this circle the length of the hypotenuse will be taking, or the radius, right? So the length of the radius will be a unit. So if I consider the circle, the very circle shown in the diagram, this one, so this will be the radius. So let's the length of the radius is equal to 1 unit. Let us now mark different axes. So this will be, let the origin be O, and this this will be our x-axis, and let this will be our y-axis. Let us mark this point as P. This will be, if I take the length, right, this one from here, this will be our baseline or our reference line. From reference line, we take an angle theta on the radius. So this is our radius, and this is 1 unit. So let this particular reference line, from this reference line we make an angle theta. So this is our basic, what do we call, is the basic construction. Then what I have done, we took this as angle theta. Let this point be A, where I have drawn a perpendicular from point P, and let this point be B, where I have drawn a horizontal from point P. Now, if we have to calculate sine theta, we very well know what is a sine theta. This will be 1 unit. So what will be a sine theta? Sine theta, we very well know, is perpendicular upon hypotenuse. Perpendicular of this particular diagram is AP. If we see triangle OAP and hypotenuse is OP, so AP length of OP is 1, we simply get AP. So our length AP will be sine theta. Let us now calculate cos theta. Cos theta is equal to base upon hypotenuse. This means our base here is OA, hypotenuse again is OP, so we have OA upon 1, therefore OA will be our cos theta. Let us mark OA as cos theta. Now I have taken here a tangent. Let this tangent be CD to the circle we have, and let us now calculate what will be our tan theta. So if we look similar triangles, that is triangle OAP and triangle CAP, we find that these both triangles are similar. If this is angle theta, and we know tangent is always perpendicular to the radius, so this angle will be 90 degree and this angle will be 90 minus theta. Alright, so in both the triangles we see that we mark here 90 minus theta. So what will be this angle? This will be again theta. From by the property of similarity of triangles, what do we get? We will get the length OA upon OP is equal to length AP upon BC. How I have calculated? This angle theta, it has adjacent side OA and this side is OP. So I wrote both these in proportions. Then this is our base side, that is adjacent. So this angle we have base side as AP and hypotenuse is PC. So again I have wrote them in proportionality. Let us now write down the values. OA here is let me take the OA and then OA upon AP is equal to OP upon PC. So OP we know is 1 and let PC be written in the same way. PC implies OA. So we can find that from If we inverse it, so we get AP upon OA. So PC is equal to AP, that is simply our sine theta. And what is OA? That is cos theta. So we easily get tan theta value as PC. Since sine theta upon cos theta is tan theta, so we can write here tan this length PC as tan theta. Now let us calculate cot theta. Cot theta. First we had seen both the triangles OAP and CAP. Now we will see the triangles OPB and BP and D. Triangle OPB and triangle BPD. Again, by similarity of both these triangles, we can see this angle will be 90 minus theta. This is again 90 because radius is perpendicular to the tangent, and this angle will be theta. So by similarity, this angle is again 90. So angle BPD, this angle will be 90 minus theta. I hope you have got this step. So we will be calculating things on this angle 90 minus, so we have understood this 1 unit, so we can remove here 90 minus theta. This will be again 90 minus theta. Right. Let us calculate by similarity of the triangles OB upon OP is equal to BP upon DP. Let me take DP on one side. So we have BP over OB into OP. We can see DP. So we can see here BP. BP here, that is this length. Let's make it with the red. This length will be again cos theta because it is opposite in a square. So again we have this length BP as, what do we have? Let me remove this line first of all. Okay, so BP we have cos theta. What is OB? OB is again opposite to sine theta, so we can easily write here sine theta. OP that is our radius, that is 1. So what do we get? dp equal to cos theta upon sin theta. So we can write here cot theta. So our length dp has come cot theta. Now let us move on to how we can find length of our cosecant, the values of cosecant and secant. Let us first calculate. Let me remove this quickly. Let us now secant theta. Consider triangle OCP and OAP. For both these triangles, theta we have common. This angle is common. So by similarity of triangles we have, if we look at triangle OCP, this will be 90°, and by similarity of triangles, if theta is this angle, then consider this as the adjacent side. We have OP is equal to OC, and in triangle OAP we have theta being the same. We have 90° here, so our base will be OA, and again our hypotenuse will be OP. OC is equal to OP into OP upon OA. OC is equal to 1 into 1 upon OA. Now, what is our OA? OA is simply cos theta. Therefore, the value of secant theta is equal to 1 over OA, or value of secant theta. From here, what we get, the value of secant theta, that will be OC, and this will be inverse of cos theta. We can write this particular length as OC is, what is it? Secant theta. Let us now calculate cosecant in a similar way. Consider the opposite triangles, right? First we consider triangle OPC and OAP. Now let us consider triangle OPD and triangle OBP. Now if this is our angle theta, this will be definitely 90 minus theta, and this will again be perpendicular for our triangle OPD. Therefore, by similarity of triangles, we can again see that our length OB, if this is our angle, then length OB will be the adjacent, that will be the base, and OP will be our hypotenuse, or let me first take the angle sides of the triangle OPD. So this is our 90, and if this is our 90 minus theta, then 90 minus theta adjacent side will be OP upon our hypotenuse. So we can see here in triangle OPD, our base is OP and our hypotenuse is OD. That will be equal in triangle OBP. Our base is OB and our hypotenuse is again OP. So OD is equal to OP into OP upon OP. That will be 1 over OB. That is 1 over, what is our OB? OB is opposite side of square OABP of side AP. So OB will be sine theta. Therefore OD is equal to what? Cosecant theta. Right. So here we have calculated cosecant theta, and let me just mark it. This will be what? This side OD will be our cosecant theta. This will be our cosecant theta. Now let us see how to calculate trigonometric identities through this unit circle, and it will be a very interesting thing. So we know what our trigonometric identities. Sorry for the spelling mistake, I just quickly wrote it. Sine square theta plus cos square theta is equal to 1. Then we have 1 plus tan square theta is equal to secant square theta. Then we have 1 plus cot square theta is equal to cosecant square theta. So these are the sum of the trigonometric identities we have, and we'll try to prove them with the help of this diagram. Here in the diagram you can see sine square theta, right? Now consider triangle OAP by using Pythagoras theorem. We have OA square plus, that is perpendicular, right? Perpendicular, that is PA square base, that is OA square, is equal to our hypotenuse, that is OP square. So we definitely calculated what is our PA, that is sine. So square will be sine square theta. What is our OA? That is cos. So cos square, that will be cos square theta, and OP, value of OP, that is radius, that is 1. So what do we get? Sine square theta plus cos square theta is equal to 1. That is our first identity. Let us now calculate our second identity, that is 1 plus tan square theta is equal to secant square theta. There might be two methods of calculating, right? You can just use the sine square theta plus cos square theta is equal to 1. Divide both sides by sine square theta what do you get? Let us first divided by cos square theta. We are calculating the first identity. Sin square theta upon cos square theta plus cos square theta upon cos square theta to 1 upon cos square theta, right? This are cancelled. Sin theta upon cos theta is tan theta, and square of it will be tan square theta plus 1. 1 upon cos square theta, 1 upon cos theta is secant theta, and square of it will be this. Similarly, 1 plus cot square theta can be calculated if we divide our first identity sin square theta plus cos square theta is equal to 1 by sin square theta. We get 1 upon sin square theta, right? And here what we can do, we can simply make it 1 plus this is the value of cot, it will be square, and this will be cosecant square theta, right? This will be the second or the third identity. This is our second identity. Now let me just show you how to calculate these identities with the help of diagram, so that you can have an idea how we can basically calculate identities through diagrams also, rather than just deriving it from one another. Now you can see the length PC is equal to tan theta, and secant theta or length OC is equal to secant theta. Consider triangle OCP. We can see our this right angle at P. This will be OP square plus PC square is equal to OC square. So OP, what is the value of OP? We can write here 1 square. PC is tan theta, tan square theta, and OC is secant square theta. Therefore, what do we get? 1 plus tan square theta is equal to secant square theta. Similarly, if we see the other triangle, that is triangle OPD. In the similar way, 90 will be right angled, 90 degree will be, that is right angled at P. OP square plus PD square is equal to OD square. So OP is our 1, square will be 1, PD is again cot, and square will be cot square theta, and OD is cosecant. So we have cosecant square theta. This is the value of the third identity. So this was all for today. I hope you have understood the diagrammatic representation of the different trigonometric ratios or functions through unit circle. And tomorrow we will be taking some more lectures on we will be taking our next lecture on quadrants and how to calculate different angles, basic angles, with the help of quadrant. So I'm sorry I couldn't upload the video for 2-3 days because there was some technical issue. Today it got rectified and I was hopefully able to upload the video. Hope you're enjoying my videos. Do subscribe, like, and share with your friends so that I can reach to more and more people. Thank you. Thank you for watching today, and let's meet in our next lecture.